I remember I started traveling late in life. I think I went to my first foreign country when I was 30 years old. It was London, and I was there on business. And I'm from San Diego, and in San Diego, we don't really have mass transit. We just drive our cars everywhere. So when I got to London, there's the tube system and the train system, and this is the way that most people used to travel. And I remember standing in Paddington Station, and there were trains coming and going, and I looked up at the board, and I saw all the different cities listed and all the different times, and I did not understand what was going on. I felt incredibly overwhelmed standing on that platform, wondering what I was going to do next. And I'll tell you, it was a learning curve, but after about 2 days in London, I felt supremely confident I could get to any place I needed to go by just using maps and using the train system. And now since then, I've worked in London with clients. So I've been to London maybe 12, 15 times. And every single time I'm there, I'm very grateful to have the train system and be confident with it. Well, that feeling of being overwhelmed, I get that feeling when I look inside Azure. And I look at all the different Azure services and offerings, and I wonder, like, oh, when should I use this one? When should I use that one? When should I use this one? I sometimes have to look things up, and I'm an Azure insider. I've been using Azure since the very beginning. I'm on the Azure MVP list and on the NDA list. I see everything going on with Azure, and I still get blindsided by new offerings and things that are coming up. And the whole thing is just so broad in scope and overwhelming that I'm letting you know that if you looked at Azure and you said to yourself, what is that service and when would I use it and how does it compare with something over here that sounds exactly the same, and even the marketing literature really feels the same, I can empathize with you. I recognize that that's a problem. And the goal of this session is not to cover all of Azure because we don't have a month. And the goal of this session is to not make you an expert on every topic that you're seeing on the board right now. The goal of this session is to lessen the feeling of being overwhelmed and to calm you down just a little bit so that you know on the data side, the Azure offerings on the data side, you know how they are used, why they are used, and who the competitors are, and then you'll see a brief demo on these products. And that's it. That's all we're going to do is we're just going to like calm this down a little bit, take you through the paces, let you see some of these products and know how they're used and what they're used, and that, that's the goal. And if at the end of this session you're like, wow, I might not have dived too deeply into any one of these topics, but I feel much more comfortable now. I'm ready to kind of attack my next project or to read some docs or to, do a getting started document, or maybe you don't even have an Azure account and you just need to start a free trial. Right now you can get a free trial in Azure and start playing with these products for free up to $150 for just being anybody. And if you go to a Microsoft event, they hand out more free money on Azure like candy. Every Microsoft employee you meet will have a pocket full of Azure cards that you could say, hey, do you have any free Azure money? And they'll just hand you a card and you can use it even more. Okay, with that said, today we're going to talk about blob storage, table storage, DocumentDB, Azure SQL Database, which is a PASS offering for SQL, SQL in a VM, which is an IaaS offering, and if you don't know what that means, I'll explain it in a second. And then we'll look at Azure SQL Data Warehouse and Azure Data Lake, and then a couple other things, and then we'll be gone. Now, I know we're only supposed to be an hour. Jason, are we hard on that hour?
No, we can go a little bit over that if we need to.
Okay, well, you guys, look, I'm gonna just keep talking. I can't see your faces, so I'm gonna assume you're listening to me. Go ahead and use the chat window. If you have an immediate question, maybe Jason could stop me and tell me what the question is. I can answer it. And, eat your lunch, drop in and out. Maybe if you don't like this topic, wait around 5 minutes, then another topic will come up and you'll like it better. All right, first thing is Azure Blob Storage. A blob is just a file. And those files can be any type of file. It could be a JPEG or an AVI or a PDF or, a bunch of JSON or HTML or a bunch of log files or anything you want. And you could save these files up into Azure Blob Storage and organize them by containers. And a container is just a very flat folder structure. So you can't have a container inside a container. What you have is you create your storage account, name it whatever you want, and then once you have a storage account, you can create as many containers as you want to create. And then once you have those containers created, then you start putting blobs into those containers. And you could organize those containers by application. You could say all the files for this HR vacation tracking app go into this container. Or you can create those containers based on function, like PDFs go here, JPEGs go here, logs go here, right? But just remember that this blob storage, the big feature of it is that it's unlimited storage. So you can store as many objects as you want in there. Right now, as of last year, there were 40 trillion stored objects in Azure Blob Storage, and that has been escalating. So I think that number's out of date. I just don't know what the current number is. And 3.5 million requests per second for files that are in Azure Blob Storage. The files are exposed through a REST API, just like a URI that you use to either surf the web or to use, RESTful web services. And you've got a storage client where you can programmatically interact with those files in .NET or C++ or Java, Node, Python, JavaScript. There's a lot of different ways that you can gain access to those files. And it's highly durable and massively scalable. And what I mean by that is, have you ever been working with a SAN and all of a sudden the SAN ran out of space and you went to the operations guys and said, hey, I need more space in the SAN. And they said, no problem. That's just going to be $50,000 in 1 month. And you said, what? I have files right now that need to be stored. And well, that never happens in Azure Blob Storage. Azure Blob Storage always has space for you. You can always put data there. And the performance is predictable. Now, it might not be ultra fast. It can be fast. It might not be ultra fast, but there's 150 millisecond performance SLA. So what that means is, in the SAN, and I've worked with many SANs before, I've noticed that the SAN vendors come and they promise performance, and if I'm lucky, I get the performance that they promised. And then I've noticed that SAN performance tends to degrade over time. So I feel like 3 years into the SAN's lifetime, it feels slower to me than the first day. Now the SAN guys will yell at me and say, that's not true, Ike, that's not true. But I'm telling you, I've worked with a lot of SANs and a lot of databases, and unless they're really maintained, they degrade. And Blob Storage doesn't have that problem. Blob Storage has that performance SLA. You know how fast it's always going to be no matter how many files you store in it. You can also make it geo-redundant. You can make it locally redundant, which means that we put it in the same data center but on a bunch of different servers. You pay one rate for that. That's $2.40 per 100 gigs, $2.40 a month per 100 gigs. And if you want it geo-redundant, you just double that, and now you've got all of that data into a different data center. So if one data center goes down, your files are still available in another data center you can fail over to. And if you want read access to the geo-redundant, then you just triple your rate, $6.10 per 100 gig per month, and now you can read the data in multiple different locations. Now, I'm going to digress for just a second. If you're worried about raw performance, Azure has a service that's not strictly related to data, but it's called a CDN, and it will replicate the data to all of its data centers that your users are at, and it will keep it in memory in ultra-fast storage, so that if you've got JPEGs for a website and you want that website distributed everywhere, then users are pulling the blobs from the close data center with lower latency and very fast storage. CDNs are very, very fast, but it's a lot more expensive. So that's why you don't want to throw a CDN over all your data. And there's some programmatic complexity in dealing with the CDN, mostly related to cache expiring. But just be aware that if you need ultra-fast, that's available. It's a different service. It's out of the scope of this course. So like I said, what kind of blobs can I have? Well, you heard me say PDFs and JPEGs and all that kind of stuff. But you can also put SQL BAK files there, which means you can back up SQL to Azure Blob Storage in SQL Server 2014 and 2016. I think maybe even 2012, but don't quote me on that. I'd have to look that up. So as a consultant, I love that because often I go to a customer, they don't have a DBA on staff. They've just got a poorly performing SQL Server and they need some help. And I say, oh, well, look, I'd love to help you, but how are the backups? And they look at me like, I don't know who does that. Who does the backups? And the minute they do that, I'm not going to trust it. So I'll say, oh, well, I'm happy to work and change stuff, but real quick, I'm just going to make a backup. And if there's local storage available for me to back up, fine, that's fast, and I know the size, and I can use the free space, fine. But sometimes these servers have been neglected, and I can use Azure Blob Storage as the backup target, and then get the backup into the cloud, know that at least if anything fails, I might get fired, but I won't get prosecuted for losing all their data, right? So, but now I've got a safe backup, right? And I have access to the data. So be aware that that's out there for you, and it's very powerful, very useful. Also, Azure Blob Storage is the engine for virtual machine hard drives in Azure. So when we use Azure VMs, we can create VHDs and disks that are using Azure Blob Storage in the back end. Competitors to this are Amazon S3. They're the big competitor, or obviously on-premise SANs and arrays like I told you about earlier. S3 is actually the very first service that Amazon ever released, and it's still their most popular service. And I don't know if you remember, but late February, S3 went down because of a database error. Actually, somebody deleted a bunch of records without a where clause in a database, and how to bring all that back up really caused some rolling restart issues for them. And I don't know if you remember this, but when S3 went down, like half the internet went down with it. It was a pretty big deal. So that was related to blob storage, by the way, just so you know that. Okay, so let's go ahead and take a look at blob storage. So I have a project here that I just call my blob storage demo. I'm going to set that as my startup project real quick. And we'll just come in here and take a look at some code right here. And what I'm going to do, and I want to just kind of show you, I've got this PNG called Hello World. It's just my own little image file that's sitting here. And I'm going to upload that PNG into my storage account. Now, just so you know, let's go ahead and sign in to my Azure storage account. So I'm going to go to, actually, let's leave that page up because I want to show you that later. Uh-oh. Uh-oh, hang on one second. I know where my internet is, but I can show you this. I can show you this on this screen. I am on a Mac, so here's my Chrome on my Mac. And if you look at on my Azure storage account and my all resources, I have a bunch of different resources over here, but I also have this Data Ike 1 storage account. And Data Ike 1 can store blobs, and it can store tables and queues and files. And I'm going to talk about blobs and tables today, but real quick, here's blobs. And then what you'll notice is I have a container here called demo container block blob that I named. That container, like I told you about earlier, and I click on that container, and no blobs found, right? Can you guys see my screen? Is the font okay? Blown up okay? Jason,
you can see it. It is a little bit tiny, though.
It is, okay. And what about the code right here? Is the code here tiny?
Yes, it is.
It is tiny. Oh, yeah. That's too bad.
Oh, wait. Let me code. Yeah, sorry. It took a second for the code to refresh. We can see the code.
Okay, good. Okay. Okay, so no files there. And let's just kind of step through this real quick, and then we'll move on to table storage. We're almost done. So I'm just going to step into this code. Now, I've got a string that's just my hello world PNG. And what I do when I want to get access to a storage account is I use two things. I use an endpoint. That endpoint was Data Ike 1. That's the storage account name. And I use an account key. And this key is my unique way of proving that I am who I say I am. Please don't memorize my key. If I come back here on my storage account that you saw earlier, if you want to know what my keys are, you just click access keys, and you can see the keys listed right here, and you can click here to copy them and put them right in your code. So with that two things, a storage account endpoint and a key, I can get access to my storage account. And then once I have access to the storage account, This is me creating a storage account object. And then once I've got the storage account object, I can say, give me a blob client because I'm going to be storing blobs. Now I'm going to create the blob container. And now I want a container reference for that demo container blob container that you saw that I had created earlier. So I've got it. Okay, create. Why'd you time out? Hang on one second. Sometimes if I talk too much, there's a, although I don't feel like I did it this time, there's about a 10-minute timeout where if I talk too much, Azure kind of times out on me. So let me just real quick just start that over again, and I'll step through a little bit faster. Okay, go down, get my storage account, get access to the container. Okay. Oh, you know what? It might be. So this is really bad news, and I apologize for this being a little bit choppy, but I don't think that this VM has, yep, look at this VM has lost internet access for some reason, and I need to troubleshoot that, and I really apologize. It had the internet access a second ago. So this is a problem with my desktop, and I apologize. This is going to be a really terrible demo if I don't have access to the internet. So let me just real quick try to figure out what's going on with the network real quick. Okay, it should work, but it isn't. So what I'm going to do, and I apologize that we're going to have to wait for this, but it should be really quick, and I'll keep talking, and we'll come back to this demo in just a second, but I'm going to reboot this VM and see if I can fix the network problem. So 1 second. Okay. Uh-oh. This is bad news, but what we'll do is we'll come back to the demo on blob storage because I definitely want to show you that. And while it's rebooting, I'll talk about table storage and DocumentDB, and then we'll come in and we'll show all the demos all at once when this is done. So I apologize for the hiccup. Okay, let's come back here. Okay, table storage. So table storage is very similar to blob storage, and it has all the same features that we talked about earlier. It has an endpoint, it has keys, instead of containers, it has tables, it has the same scalability and redundancy patterns, and this very similar pricing, and it's very, very fast. So what is table storage? Table storage is a NoSQL key value pair solution. What that means is, now, when I tell DBAs this, that table storage is a key value pair, in their head, they're thinking of just one key and one value for that key, and they think table storage is relatively useless. But the reality is, table storage is not, it's an actual full table. So I can show you what that looks like here. So if I go back to my blob storage account in Chrome, and we look at my overview, and we look at the tables, so I've got a customer table here, and that customer table, all records for the customer table are going to be stored in one physical table. And that table can have columns. Those columns have data types. We can have hundreds of columns in the customer table. Like really, it's a very complicated type. And those columns will map directly to my object's properties in C#. So that customer can have a first name, a last name, an email address, a phone number. It can have a title, it can have a marital status or a gender or a birth date, or all those things can be stored in table storage. Now, you might ask yourself, why do I have table storage if I already have SQL Server? SQL has tables. Why not just use SQL's tables? The difference is Azure Table Storage is very, very, very fast. And I got a quick story. So I worked with a customer probably 3 years ago, And this was before Azure SQL Database had performance SLAs. And we'll talk about that in just a second when we get to that section. But we wrote a full solution on Azure SQL Database. And in dev and in test, it worked fine. But when we put actual customers on it, it folded. And we figured out that it folded at about 60 transactions per second, which we'd never tested. It was our mistake, and we never tested 60 transactions a second. So we were getting timeouts and errors all the time, and the project was failing. So we contacted Microsoft and we said, what can we do about this? Like, we're really hurting right now. And Microsoft said, rewrite it for Azure Table Storage, and you won't ever hit the scale problem as long as you partition the data correctly. So we furiously rewrote this thing. We put all of our data in table storage, and it was like turning on a performance switch on our application. It was lightning fast, very, 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 very fast. Now you might ask yourself, well, Ike, if it's so fast, then maybe I should just not be using SQL at all, right? I won't use SQL Server anymore if we've got something that's so fast like that. Well, here's the problem. In Azure Table Storage, there are no foreign key relationships. There are no indexes. There are no stored procedures, no triggers, no views, right? It's just tables. And you're like, well, what happens? I mean, no foreign keys or no indexes. That's a good one. What happens if I want to retrieve my customer's data by birth date? Well, guess what? That's another table. And you're keying off the birth date. And then what's the other column that you're going to have in the from the birth date column? You're going to have the customer ID, which is the ID in the customers table. What I'm telling you is, if you're going to use Azure Table Storage and you're going to be querying off of multiple values, you're going to create those indexes by hand. You're either going to create them in a Redis cache someplace, or you're going to create another table for that index that's going to have a pointer record to it. So that's a lot of work, right? And if you don't have the scale issue, and you don't have, you don't want to do all that plumbing code, then Azure Table Storage really isn't for you. But for some use cases, it might be for you, and it's good to know how to use it and you know what it's good for. So in this case, I might have a bunch of movies, and I'm partitioning based on action movie or comedy movie or drama movie. Partitions mean I'm storing this data on one specific server, on one specific shard for partition tolerance. So what that means is I can kind of focus the reads and writes by the genre of movie in this case. Azure Table Storage does not charge you for compute. It only charges you for storage. So it's really cheap, relatively cheap. So you can shard as much as you want, not worry about getting charged for it. The competitors to Azure Table Storage are at Amazon DynamoDB Table Storage. Now, DynamoDB is kind of confusing because Amazon puts a lot of things under the DynamoDB umbrella, and in this case, they put their key value NoSQL solution under DynamoDB called Table Storage, and it's very popular. People love it on the Amazon side, but Azure competes very well with it. Okay, so sorry about that demo kind of messing up. Let's just see if my thing came back online yet. Oh no, this is terrible. I apologize, guys, but this might take a minute, but I still have more lecture, and then we'll just do all the lab together, and I think we'll still be able to work this out. Okay. So the next topic is Azure DocumentDB. So Azure DocumentDB is a very exciting project, and it's one that I'm very proud of. I've been using DocumentDB since the beginning. I hope that you'll see some of the magic to DocumentDB as we keep talking. Now, I recognize that the audience here are data professionals that are relational data professionals, right? I recognize that you guys have been working with SQL Server for a long time, and that JSON and JSON document storage might be relatively new to you. So let's just talk about this for a second. When a developer thinks about data, a developer almost always thinks about an object hierarchy. So in their head, they see data as a parent-child relationship. And they use words like this contains this, and this contains that, and this contains that. That's how they think about data. When they think about passing data along, they think about the hierarchical nature of the data, which is why typically junior developers and younger developers in particular, they have a very hard time thinking relationally. When you guys think about data, you guys are thinking about table structure. You're thinking, like if I say, hey, I want to write a new app and we're going to do order transactions, you're already in your head thinking about, well, we're going to need a customers table and an orders table and an order details table, and they're going to have these foreign keys and these relationships. And what you're doing is you're flattening the hierarchy in order for SQL to store it. And you're doing it for a lot of good reasons, right? You don't want repetitive data. You want to only update data one place, one time, one transaction, right? All good reasons, right? But for a developer, that's not natural to them. And they don't necessarily care about data duplication. And they also, like, for them, when they have their objects in a hierarchy, they have to then do what they call shredding it. And they have to shred that hierarchy and flatten it into that relational format so that it fits into SQL Server. And in order to accomplish that, they have to write a lot of plumbing code. So they're either writing SQL or they're using Entity Framework or in Hibernate or Dapper or one of the micro ORMs to kind of connect the fact that they've got this object hierarchy in their head and they know that the database wants it flattened, right? And they don't really like it. It's not really fun for them, and they complain about it in private all the time. And then if you guys are data professionals, these guys are probably complaining to you about it. And imagine just, I know you guys have been doing this for a long time, but imagine you're a junior developer and you're just learning SQL, but you're writing a mobile app and all you really want is your mobile app to get to the mobile store so that you can, get a raise. And you say, okay, I need to save an order. And you save an order and it says, there's no foreign key for customer. And you're like, what? Like, yeah, you have to save a customer before an order. Oh, okay. So now I'm going to save the customer. Now I save the order, and it says, no, you don't have a vendor yet. Oh, wait, I've got to create a vendor first. So in a relational database with foreign key constraints, the way it's supposed to be, data integrity matters so much that the order that you insert matters, and the order you delete something matters, and even potentially the order you update matters, right? And that order, it's confusing for junior developers, and they make mistakes in it all the time, and they get frustrated. And so now a JSON storage system like MongoDB or DocumentDB comes along, and they are told, look, you don't have to worry about order or anything. You just, that object hierarchy, you just click one button, save the object hierarchy, and it will automatically serialize it to JSON and store it as JSON. And that is like extremely attractive to a brand new developer, and even some experienced developers are really excited about that. So if you look at my screen up here, you're going to see a bunch of JSON right there, right? First name, last name, is alive, age, right? Do you guys think that's easy to read? Like, even if you've never seen JSON before, like my mom, right? My mom thinks that I teach Microsoft Word and Outlook for a living, and she has no idea what I do, right? And if I brought my mom over here and I said, Mom, what do you see there? He would say, oh, I think it's a person and their address and phone number, right? JSON is very easy to read. It's very simple. That's the strength of it, is it's very powerful and yet very simple. So JSON was created as a reaction to XML. XML is a terrible language. It's very verbose, it's highly structured, it has a lot of rules involved, it's easy to make those rules have mistakes. It's a very difficult language to work in for a lot of people. So Brandon and Ike said, hey, you know what, I hate XML, we really should be throwing data around like this, and he wrote a blog post about it, and when he wrote that blog post, 1 million people said, you know what, he hates XML, and I hate XML too, and almost overnight, JSON became lingua franca for data exchange on the internet. So now we pass JSON around in REST services, we pass it around all over mobile apps, we serialize our data as JSON. JSON's everywhere. So being told that you could just save your data to a developer what is now the native format of data is absolutely fantastic. Unlike table storage, in DocumentDB, every one of these every one of these columns, properties, are indexed automatically for you. So The index is automatically created. It's fire and forget, and that means that if you want to query DocumentDB, pull the Anderson record out of here, you could just say, give me all the records where last name equals Anderson, and boom, you get all the records where that's true. And it's all on SSDs, it's all super fast, and it all comes back to you very quickly. In addition, DocumentDB has a SQL-like language that you can use to interact with it. So this language right here, select this from foods where f.food group equals snacks, that SQL language you can write queries for, and it will bring the data back to you in your application automatically. It's not Transact SQL because remember, JSON's hierarchical, so sometimes we have to like dive a little bit deeper into the JSON hierarchy, pull some data out, and then work with it. And I can show you in code as soon as my machine comes back up exactly how that works. The competitors to document, yep.
Yeah, and it looks like you might can talk about it here in just one moment, but somebody had asked, is DocumentDB just a MongoDB knockoff?
Well, so that's, you know, that's like saying are all JSON document stores the same, right? And DynamoDB has a JSON document store too. It's very popular, and it has a lot of the same attributes as MongoDB. So DocumentDB has a few things that make it unique. That automatic indexing makes it unique. It also is very easy to geo-replicate, and that has been criticized that Mongo has a more difficult path to geo-replicate. But yeah, it is very similar. In fact, you can use a MongoDB API over DocumentDB, and your MongoDB front-end apps will work with it. So it offers a migration path from Mongo to DocumentDB.
Sounds good.
And then
Ike, after the slide, somebody did ask if you could show the outline slide one more time.
Yeah. Okay. So I can do that. It's just right up here. This is real quick. That's the outline. Take a screenshot real quick, and then we'll take a look to see if my machine came back up, and I can show you some demos. We're good?
Yep, we're good. That's all the questions you've got so far.
Okay. All right. Looks like my machine came back up online. And just real quick, let's see if I have internet access. I always test with CNN because it doesn't require HTTPS. Please come up. Please come up. Boom. Okay. All right. So let me bring my Visual Studio up. That'll take 1 second. Bring my project up. And I know I've got debt with you. I know I've got to show you blob storage first, then table storage, then DocumentDB. All right. Any other questions while we wait for this thing to come up?
Nope, no other questions.
Okay. DocumentDB, by the way, is very good for mobile apps, for gaming apps, for IoT apps, for any time we have a lot of data where we care about all the data and we want the data to be fast. DocumentDB is very good. And DocumentDB charges you by something called an RU, and what you do is you have a sliding scale for scaling up and scaling down. So if you need more RUs, you can go really, really fast, or if you need fewer, you can go slower. It also charges you for storage. It's, I think, 25 cents per month per gigabyte of DocumentDB space. But, you know, that can add up pretty quick. I've got a customer that has probably $2,500 a month in DocumentDB storage. So it can get bigger. I don't know why this is going so slow, but I think it's just because it came online for the first time. So let's just hope that it speeds up. Also, the way you gain access to DocumentDB, once you have the storage account, is if you want to query DocumentDB, you just use link to objects, the same link that you guys use in C# for the last 10 years or so. So it's really, really easy to retrieve data. You're using a language you're already familiar with. It looks like SQL. And it's really, really easy to write data. And I'll show you that in the demo in just 1 second. So I don't know why this is so slow. You guys, what's funny is I did all of these demos right before the session started and everything was working. And then just made a mistake. I don't know what I did. I think I'm gonna kill this and try to open it again. Okay, let's try that again. All right, let's see if this was better.
And while we're waiting for this to come up, Ike, did you want to go on and talk about another product real quick? That way.
Yeah, I think so. I just thought it would come up really quickly, and I don't know why it isn't. So yeah, we can do that. So let's talk about this slide for a second. So we're going to switch off of DocumentDB, and we're going to talk about your SQL Server options for just 1 second. So for those of you who aren't doing anything in Azure right now, what is kind of like the ideal solution in Azure is what we call, and any cloud, what ideal in Google, ideal in AWS, is a platform as a service offering. And what platform as a service, if you go all the way to the upper right of the slide, you'll see platform as a service right up here. And what platform as a service says is, look, you don't even know what operating system you're on. You don't even know what version of SQL Server you're using. So that version of SQL Server is kind of similar to SQL Server 2016, but it has some features of 2017, and it has some features that haven't even made it into the on-prem service product yet. Like here's a good example. Azure SQL Database up here on Platform as a Service has a feature called threat detection, where it will automatically detect that you have SQL injection attacks happening. And it will stop those SQL injection attacks happening at what they call a gateway service. So when you use Azure SQL Database, you don't patch the operating system. You don't upgrade the SQL Server version. You don't put virus protection on. You don't manage the disks. You don't manage memory. You don't manage rebooting it if something's wrong. Like, all of that is done for you behind the scenes. All you do is you create a database and you immediately start using it. And that's a very kind of cloudy way of interacting with data. DocumentDB is also platform as a service. Azure Table Storage, also platform as a service. And in this case, this is a relational data store with all the things you love about SQL Server. Indexing, store procedures, views, check constraints, primary keys, identity, foreign keys, user-defined types. Everything that you're using, almost, there's a few things that it doesn't have, that's in that platform as a service offering. And all you have to do is just right-click in Azure, new database, and 2 minutes later you have a database and you can use it and start putting data in it. Now, right down from that, it's called infrastructure as a service. And infrastructure as a service is a virtual machine that's in Azure, where Azure manages the memory and the CPU and the network cards and the disks and the power and the air conditioning and the fire retardant and everything involved in managing a data center, Azure manages for you. But you have a virtual machine, just like you'd have a virtual machine if you were using VMware or Hyper-V in your own data center. And that means that you have to manage patching the operating system. You have to manage upgrading SQL Server. You have to manage your disk backups. You have to manage fault tolerance. But you don't have to worry about your network card, threat, blue-green, DOS attacks, red-blue DOS attacks. You don't have to worry about, if a drive fails. That's all done for you. That's all included in your bill. And so those are the two ways we go into the cloud. So now that you know the differences, let's talk about the platform as a service offering, which is Azure SQL Database. So Azure SQL Database, all the data is backed up for you automatically, and you automatically get a point-in-time restore. If something bad happens to your data, like let's say at noon, some person deletes all your customers, you can restore the backup all the way up until 11:45, and then you get all your customers. Now you've lost 15 minutes of data rather than all of the customers, right? So that's very powerful, and it happens for you automatically. It can be geo-redundant, so you can automatically replicate data to another data center so that you can fail over if something happens to the data center. It can be scalable both in performance and in data size. You can scale up to get what they call DTUs, more DTUs per second, or scale down. You can scale all the way up to 1 terabyte of data right now, which isn't that big, but you know, is pretty good for a lot of applications and use cases. It's not feature complete with SQL Server in a VM. Like, we don't have SQL Server agent. We can't install our own certificates for TLS. We have to use theirs, you know, TLS. But it does have TDE encryption, which means we can just check a box, and all of a sudden we have encryption at rest, which is a very powerful SQL Server enterprise feature. I was working with a customer recently, and they failed an audit, and they said, we need to have encryption at rest for our backups and for our files. And I said, oh, you're using standard edition. You need to go to enterprise edition. And they said, oh, how much will that be? Like, that'll be $50,000. Like, no, I can't do it. Well, if they were using Azure SQL Database, they would just hit the checkbox, and then automatically they would have the TDE encryption at rest automatically. So what happens when you create an Azure SQL database? Every single one, it's included in the basic price, is you get 3 physical replicas of that database automatically. You get a primary, and then you get secondaries. And if the primary fails, it automatically fails over to one of the secondaries for you. This is a link, by the way. My slides are all online. You can go to my website, ikeellis.com, and download the slides from SlideShare. This is a link to the places that it will tell you what are not supported features of Azure SQL Database. This is the performance SLA, so you can scale up. You can go to scale up in size and scale up on DTUs all the way up to 1,750 DTUs on a P11 instance and 1 terabyte database size. But you know, you pay for that, $7,000 a month for that type of performance. That's a lot. The competitors to Azure SQL Database are Amazon RDS. Amazon RDS is the platform as a service database offering on the Amazon side. Amazon RDS lets you use SQL Server if you want, but you can also use MySQL, Postgres, Oracle. That's the only ones I know for sure. Oh, well, and their custom offerings like Aurora DB you can use. All right, let's see if that ever came back up. And it looks like it might have stabilized. And if I open up my project, let's hope this works. And we'll demo that really quick, and then we'll talk about Azure SQL Server in a VM, and then we'll get on to Azure SQL Data Warehouse and Data Lake. And then we'll be done. So hopefully we can do that pretty quickly because we have 10 minutes. Well, I'll go probably a little bit older. Okay, so hold the question real quick, Jason. Let me just show you blob storage real quick. So where I was, as I was walking you through uploading a file into blob storage. And so I stepped through this code, and remember, I told you that we create a storage account by having an endpoint name and a key. And so I submit that key to the storage account that says, hey, I am who I say I am. That's my security. And then I go get my container. And that container is called demo container block blob. And now that I've got the container, now I go get that string, that hello world.png, and I create a block blob object. And then I upload from file async that block blob object with file open. And now that it's up there, I can go retrieve it again using a URI. And the URI looks like this. It's just dataike1.blob.core.windows.net/demo container block blob/hello world.png. Now I can prove that by coming back here and just refreshing. And oh, actually, that's my table storage. Let me go back to my blob storage. And then I go into my container, And there's Hello World PNG. It came up May the 4th and 10:49 a.m. So I'm not pre-baking the turkey. That file is there and I can download it or upload more files or do whatever I want, right? Okay. Also, I can use something called an Azure Storage Manager, which is a free tool that Microsoft creates for you that is open source and totally usable. And this tool is great for managing blobs. Oh, hang on one second, let me bring that up. Azure Storage Explorer 6, here it is. So when I want to interact with a storage account, guess what I need? I need that endpoint name and I need the key. And once I've added that with the key, it gives me access to everything under there. And here's my blob storage container and here's Hello World PNG. I can upload more files or download files. This tool is a very easy graphical tool to use to deal with your blobs if you don't want to deal with it in code. It still has some limitations. In some cases it's slow, so you might want to know that there's another tool made by Redgate called Azure, let's see. Where is it? It's Azure Explorer here. And this Redgate product is free, and Redgate makes it, you can download it right now. And you can do the same thing that Azure Storage Explorer does, but it's easier, it's faster, it lets you work with multiple files a lot easier. It's in general just a more pleasant experience. So and there's Hello World PNG in this tool. So just be aware that that tool exists and it's very useful. Okay, that's Azure Blob Storage. Now let's take a look at Azure Table Storage. So I'm going to make that my startup project. And then here, real quick, I'm just going to set a breakpoint, and you're going to see a lot of things that are very, very comfortable to you. Okay, so yep, this is fine. So we'll go ahead and start this. So the first thing I'm going to do is I'm going to create a table account. And the way I create the table is first I need an endpoint name, like Data Ike1, like we talked about earlier, and I need a key, just like blob storage. Once I have those two things, I can create a table. And the table that I'm going to create is the customer table. So I click here, and you can see my table name is the customer table right there. And then I create it. And then once I've created it, now what I can do is I can create a POCO. This is just a customer entity is my code right there. And that customer entity has an email address and a phone number, and it has a partition key and a name that I'm using for last name and first name. And if I step through that we can inspect that POCO, and you can kind of look over it. Here, let me return it really quick. This is the POCO definition, right? That's my class. And then if I hover over it, you can kind of see, oh, the customer's null. Let's populate some values. And now you can see this is my customer all populated with real data coming out, right? And now that I've got that customer populated, I hand in the table, I hand in the entity, and I just call insert or merge entity async. This is code that I wrote that really the magic is this line of code right here. I create a table operation with the entity that I care about. I'm saying insert or merge, and then I'm passing that table operation in to the table object execute async. One line of code, right? And I run that, and I take the result back, and I hand the result back. And now, just to kind of show you what that looked like, if I come back to my tables, before we had a customer table here, right? Okay. Inside that customer table, let's go back and look in my Azure Storage Explorer. Here's tables, here's the customer table, and look, partition key, row key, email, phone number. I didn't use an ORM, right? I didn't have to write a bunch of plumbing code. All I said was take this entity and save it, and it saved it for me automatically. It took the columns that existed in the POCO and it created them as columns for me. I didn't even define the schema. I let the POCO define the schema for me. So if the POCO changes, the schema can change. And it's a very powerful method for a developer. Developer didn't really have to think of very much while they were serializing their object out to disk, right? And because of partitioning and because of fast storage, it's very, very quick and cheap, very affordable. Okay, I think that's enough of that. I could show you deleting it or updating it, but I think you get the hint. It's just more of the same, one line of code to do those things. Okay, that was table storage. And now that you've seen that, let's take a look at DocumentDB. I know I'm throwing you all over the place and kind of throwing this at you, but let's look at it. Okay, so DocumentDB, there we go. Actually, you know what? I didn't have any breakpoints set, so let's start that over. Let's put a breakpoint right here. Okay. All right, the first thing I'm going to do is I'm just going to create a document. Now, in my little application, I created a POCO in my models folder for a conference. And I'm just pretending that I'm managing a conference, right? And conferences have sessions, and they have attendees, and they have speakers. And a speaker and an attendee are both just a person. So this is my session. It has, 5 properties on it. And this is my person. It has a few more properties, just name and employer. And then when I create a conference, this is the creation code where I'm saying, okay, this attendee goes to this session has this speaker, and you can kind of see the hierarchy in the POCO, right? When I told you that developers think of their data in a hierarchical fashion, this is how they write code. This is how they write C#. This is how their data gets stored to them. And so this is very comfortable, particularly to new developers. It's very comfortable. So once I've got that kind of hierarchical nature of the data let's go ahead and serialize it out to JSON. So how do I do that? Well, I create a DocDB client. Then once I've got the client to the DocumentDB account, DocumentDB has a database. And in my case, I'm calling my database conferences. And so it's pretty simple code. I just take the client and I say, please create the conferences database for me. And I already have it, so it doesn't need to create it, but it's just a create database async call. Once I've got the conferences database, I need a collection. And you could think of collections as basically tables that store similar data in them. Now, the difference is tables have a very structured schema, and JSON documents don't need that kind of structured schema. So you can throw documents of different types into the same collection. Collections are also the thing you'll scale in DocumentDB. So if DocumentDB needs more power, you'll scale up the collection independently of all the other collections. In this case, I'm going to create a collection in my conferences database called fall conferences. So in order to do that, I say, hey, go get that collection if it exists. If it doesn't exist, it's just create document collection async to hand that collection back. Now that I've got a collection, I can begin to store my documents. And in this case, I'm going to create a couple of brand new conferences, Conference 1, Conference 2, and Conference 3. What does that look like? Well, here, this is me, hydrating the class, right? Giving properties to all the class. I'm going to actually step out of this code so you don't have to look over all of it. Now that I have it, I take that POCO and I create on the client account, create document async, take that object. Now look, this document object, I didn't write this code, right? This is just that POCO handed in as a type. And look, it has a start date and an end date, and it has sessions, and those sessions are 0, 1, 2, and those sessions have attendees, or those sessions have speakers, or a start date, right? That entire hierarchy is comprised in this one class that I passed in. And now I just save it. That create document async creates that document for me. And I'm going to step over it because this does the exact same thing 2 more times. And now I have 3 documents in there. Now, how do I prove that? Well, if I come back here and I look at all of my different things here, this is my conferences database. And I'm going to, if I zoom in, did it zoom in for you, Jason? Did that zoom in for you?
No, not really.
Oh, man, okay. Well, we don't really need to stare at this because what I'm going to use is a product here called Data Explorer. And Data Explorer is in the browser, and there's my conferences database. There's my fall conferences, and if I look under my documents, those are my 3 documents there. And if I click on that document, you will see the JSON right here. So that JSON is, editable, right? I can say like the name of this conference is, hi Jason, right? And I can save it, update that document. Now I just updated that in line, right? If I go back to my code, let's keep stepping through. Okay, now let's query it. And I can say, okay, do the same thing. Go get the client, go get the database, go get the collection, and now once you have it, let's get all the documents out. So it says, look at this line of code right here, what is that? That's just link. I just say, hey, go into that collection and give me every JSON document that's in there. And once you use the link, you get all the collection back, the enumerator back, and now you can just enumerate it, and you could say, okay, give me the very first one. And what's the name of the very first one? It's Conference 1. Hi, Jason, you just watched me edit that in line, right? So I just edited that and it worked. And you could do it again and again. And now if we go back to our command window, you can see, the conferences are iterating through here, right? Okay. All 3 came back, right? There's all 3. All right. Okay. So that was one way to do it. And I'm just going to show you a couple other ways real quick. So that was one query. This next query is a little bit different. So let's look at that. So what kind of link is that on this line? Right? So we have inline link too that we can use. So both types of link work. And then we say, hey, give me everything that equals a very specific name, conference 1. It's not going to find it because I changed the conference name for JSON. And then the next way that we can query it, oh, hang on, read key. Look, what's this on this code? This is SQL inline. And I'm saying, hey, please give me every conference with a very specific start date, where the start date equals what? 11/1/2014. And so I step through, and it says, I found one. And it's conference 1 has that start date, and it shows that conference, So I'm proving to you that every single property in that JSON document is indexed, and you can use it as a query. And that happens out of the box. You didn't watch me create those indexes, right? So everything you're seeing live. Okay. Now those 3 conferences all have, I don't know that start date really applies, but I don't know. We'll figure that out later. Okay, so that's querying data. And real quick, if we want to just look at saving data, I want to show you that, and that's this update. So I'm just going to kind of go in there and not execute the code so that we don't waste the time. But here is the update code is just this, replace document async. It's 1 line of code. So do you remember before I told you like a developer would have to like shred the data, flatten it out, know the relationships, know the order. In JSON, in order to make an update, for DocumentDB, 1 line of code and the thing updates and it just replaces the whole document going up. Okay. Another very powerful aspect of DocumentDB is we have store procedures, triggers, and functions that we can use. And the difference being that our store procedures in DocumentDB are created using JavaScript. And that's very comfortable to JavaScript developers because they're using JavaScript if they're Angular developers or they're React developers or Durandal developers. They use JavaScript if they're Node.js developers, and they can use JavaScript in the data tier too. So where that's powerful is they're using one language for the front end, for the middle tier, creating web services, and for the back end, creating store procedures. So really a developer could know JavaScript really well and never really get out of it. And you can see why that would be very comforting to them. Okay, that's the DocumentDB demo. The last demo that I promised you is really, I don't think I'm going to demo it. It's Azure SQL Database, and the reason why I'm not going to demo it is it's kind of boring. Azure SQL Database is just a SQL database, and you've used them for 30 years, and there's really no difference here. So you're going to use it in much the same way. I think later this year, Jason and I talked about doing a demo, probably another hour session, where we're going to talk about best practices with Azure SQL in a VM and Azure SQL Database. So it'll be 1 hour on how to write apps for with those products. Okay. Now, are you guys still with me? Looks like I actually held your attention, which I'm surprised. Nobody really dropped off. Yep. So I appreciate your patience working with me through those demo issues. The next thing I'm going to go quick is just Azure SQL Server in a VM. I talked about that already when we looked at that chart. You manage your backups, you manage always-on replication, you manage the disk, you manage patching, but you don't manage hardware failure or network infrastructure or purchasing the hardware or anything like that. So there's some performance considerations. Mostly, remember, SQL Server is I/O bound. The disks need to be fast, and just about all SQL workloads, the disks need to be fast. And if the disks are fast, everything will perform better. Memory will perform better, CPU will perform better, everything will be much faster. So use premium storage. Use a VM size of DS3 or higher for SQL Enterprise Edition. Use 2 P30 disks for TempDB and for data files. Keep your storage account and your SQL Server VM in the same region so you don't have high latency. Disable Azure geo-redundant storage because we don't need it. SQL will use always on for redundancy. We don't need the overhead and the higher latency. And then avoid using operating system or temporary disks for database storage. And what that means is if you have, if you're going to use database storage, create a separate disk in Azure Blob Storage and keep it over there, because nothing is guaranteed to be the same when data changes in a VM. So just be aware of that. Okay. The competitors to Azure SQL in a VM is EC2. Amazon EC2 is hugely popular. That's their VM storage in the cloud. That's like their Hyper-V in the cloud. All right, now we're going to move on to the last two, and I think we'll be done in about 15 minutes if you guys are trying to wrap up or go to a meeting. So Azure SQL Data Warehouse is a massively parallel processing system that's built on SQL Server. And what that means is that we will take data and we will spread that data across multiple SQL databases. And then once that data is spread, if we have a query, like let's say we want to know the highest selling product by day of all of our sales, we could send that query over SQL Data Warehouse. SQL Data Warehouse will split that query up to the specific nodes. We'll go gather the results of that and hand the results back to you, spreading the load of that query across all the different nodes by compute. So that is very standard in MPP. That's what Hadoop does. That's what Amazon Redshift does. That's what Teradata does. That's what Netezza does. That's what Vertica does. They all do something similar. So what makes Azure SQL Data Warehouse different? The first thing is you get to use Transact SQL to query all the data, which is very powerful. You already know it, and you can use it. It is also very scalable. You can store up to 1 petabyte of data in Azure SQL Data Warehouse. The third thing is if you pause Azure SQL Data Warehouse, you only pay for the storage. The compute doesn't keep charging you when you pause it. So I have it. It's very expensive, by the way. So just keep that in mind. The reason why you'll want to pause it is because you will be in pain if you don't. It can be very, very pricey. So if I go back to my Azure dashboard, I have a data warehouse called Azure SQL DW Ike. And you can see right now I paused it because I don't want to pay. So what I can do is just start it. Are you sure you want to start? And now it starts. It just takes a minute to resume. If it's a small amount of data, it takes a minute. Sometimes it can take a little bit more. And now once it is resumed, I can interact with it using SSMS. So that's my Azure SQL, let's see, that's not the right connection string. It's Azure SQL, oh, second. Uh-oh, let me change my password real quick. So it's still resuming right now, so hang on one second. Let's see this resume. Okay. As it resumes, let's keep talking about it for just one second. So Azure SQL Data Warehouse is not meant for OLTP data. It's meant for analytic data. So what you're doing is you're storing a ton of data in it, and then you're querying it. And you're really thinking about the querying as being pretty minimal as far as concurrency is concerned. You're really only going to have 32 concurrent queries at a time, and we're doing that because we want to reduce resource contention. So the 33rd query is just going to have to wait for a query to finish. You might look at that and say, oh my gosh, that's way too low, like we can't use it if it's like that. But think what we're doing in an MPP environment. What we're trying to do is we're trying to get consistent results that are, maybe it's a little bit slower than we're used to with SQL Server, but it's consistent. So we know that these queries will always return in a specific amount of time. I don't know if that time is 30 seconds or 10 minutes, but we know that a set amount of time, a query is going to come back and we'll have a result back. So, and also keep in mind that when we do analysis, we're usually dealing with a lot of data. So we're saying, hey, go get all this data spread out across these 12 nodes and then hand me back the records that I care about so that I can do some aggregation against it or put it into Excel or put it into Power BI or load a cube someplace, like an analysis services cube. So those queries typically fan out, right? You say, hey, go fan this out to all the different nodes, go get the data and bring it back to me. And again, very important, it's not an OLTP workload. It also scales based on a DTU, which is a data warehouse unit, or in this case, DWU. But that is very similar to the DTUs that you saw over on the Azure SQL Database side. It's done in increments of 100. I would start very small because I can show you this in my browser. If we come over here under scale, this is my DTU, and it starts at 100. And it can scale all the way up to forever, right? Now, what happens? That DTU, and I don't know if you can see this, it's $1.51 per hour for the lowest setting. And then as you scale it up, now you're going to, $15 an hour here in the middle, all the way up at the very end to $6,090 an hour. So that can get pricey, which is why we talked about pausing it earlier. Let's take a look and make sure that it's online, and it looks like it's online. And let's take a look and see. Okay, looks like everything's good. Now, see this database name is Azure SQL Ike.database.windows.net. So I'm going to use that in my connection string. And let's see, anything else? Okay. And there's my connection string. So if I want to use it in code, I can use that connection string in code. All right. And let's come back. Okay. All right. So now I'm connected to Azure SQL Data Warehouse, and I have this database, and this database has tables in it. And if I click new query, and I say select star from dim customer, and I query that, Let me pick the right database. And this is me using an MPP system with SQL Server Management Studio, writing Transact SQL and interacting with this resource. Now, and if I want more compute nodes, I just scale it up and I pay for more. And if I want less, I scale it down and I pay for less, right? Like that is enormously powerful here. Now, there are some limitations. And let me tell you what those are. And you're not going to like them, but you'll learn to live with it because it's still very powerful even with these limitations. So we can't use these data types: geometry data type, hierarchy IT data type, image data type, SQL variant, sysname. We can't use those data types. We can't use primary keys. We can't use foreign keys. We can't use indexed views. So all of these things are taken out because of the overhead in an MPP environment. So it's not like Microsoft said, oh, we're just going to hamstring you so that you can't use this. It's because these are very difficult technical challenges to work when we're spreading data across multiple servers. But Microsoft knows that you complain about it. Specifically, there's a couple things in here I'm under NDA for, but I can tell you that coming soon, a couple of things on this list are going to be supported pretty quickly, so stay tuned. Maybe within the next couple of weeks. I don't know if you know that build is coming in the next couple of weeks, so stay tuned and we might see some announcements related to this. The main competitor to Azure SQL Data Warehouse is Redshift. Redshift scales compute and storage together, so you end up paying 24/7 for it. You don't end up paying that in Azure SQL Data Warehouse because you can pause it when you're not using it. All right, and that's Azure SQL Data Warehouse. Now let's talk about Data Lake. Okay, Jason, you had a question. Did you have a question?
Sorry about that. There's a couple questions that have come through, but it might make sense to hold off until the end.
Okay, this is the last product, and then we'll finish up.
Okay.
So Azure Data Lake is also an MPP. So that means that in Azure Lake we have a lot of requests. And you might say, well, wait, like you just showed me Azure SQL Data Warehouse as an MPP. Why would I care about Data Lake as another MPP? Well, I'll be brief, but because we could talk for hours on Data Lake. One, it's a different ecosystem. So it doesn't use Transact SQL. It is more Hadoop-like. So you can use Hadoop tools that you're used to using, like Storm and Flume and Kafka and Spark. So you're kind of getting out of the traditional Microsoft ecosystem and you're going over to more of a Hadoop ecosystem, although it's not really, one of these components isn't really built on Hadoop, but it does have a compatible Hadoop API. That's one difference. Another difference is that in Azure SQL Data Warehouse, you scale and then you use it. In Azure Data Lake, every single job can scale differently from every other job. So you can have one workload that you scale high and you pay for, and you can have another workload you scale low and you pay for. So that means that your work items scale separately from each other. And that means if you have a job that is critical that it finishes quickly and you have the money, you pay. If you have a different job that you don't care if it runs, you make that a much lower account and you pay a much lower rate for that. Scaling for the workload is very flexible, very, very powerful. Now, a data lake in general is just an enterprise-wide repository for every single type of data that you collect. So you can throw relational data in there, you can throw CSVs and TSVs and log files and JSON and movies and anything you want you can put into the data lake, very similar to blob storage. And that data lake is a generic data architecture term that we've used in Hadoop for about 5 or 6 years now. And typically Hadoop is the way they implement data lakes. Although on the Amazon side they use S3, on the Azure side we use Azure Data Lake, and then people use Hadoop both on-premise and in the cloud all the time. In Azure, Data Lake is actually two separate products. It's Azure Data Lake Store and it's Azure Data Lake Analytics. Azure Data Lake Store is very similar to Azure Blob Storage, except it has an HDFS interface over it. So HDFS stands for Hadoop Distributed File System. And what that is Hadoop's file system for storing files that are very, very large. So if you had a very large file, like you had a 30 tera file, maybe you wouldn't want to put 30 tera on one server. So what you could do is spread that one single file across servers, and HDFS has a name node record that a name node server will store where that file is stored everywhere. And it will do things like, oh, one server went down, let me go find that data on a different server that has it replicated, right? So it's a very robust distributed file system across multiple nodes. Azure Data Lake Store doesn't implement actual HDFS. The way they implement their data, they don't really tell you. But it is petabyte scale storage with an HDFS API over it. Now, the reason why that's important is because you can run Hive and Pig and all the typical, Hadoop products that you're used to using over Azure Data Lake Store and not use Azure Data Lake Analytics at all. You can avoid Azure Data Lake Analytics if you want. Azure Data Lake Analytics is the job engine for Azure Data Lake. That's how you actually submit a job and run a job. The way you create a job in ADLA is using uSQL. uSQL allows you to use C# in the background. Now, I don't have time to show you this. I was planning on showing you this, but I have to bring up another VM. But what I can do is go back to my dashboard here. And in my dashboard, I have Azure Data Lake Store and Azure Data Lake Analytics. Here's Azure Data Lake Analytics. And I can go ahead and look at all my previous jobs that I've run. I've run a few of them. And if I click on this job, I can say, please duplicate that job, and you can see it. Now, this right here, I'm going to try to zoom in. That looks kind of like SQL, right, that I can use. And I can set the number of AUs up. It's 3 cents per minute per AU. So if I scale it now up to 40, it's $1.33 a minute. And if I scale it back down, it's 1. Now, if I submit this job goes to my Azure Data Lake Store, and it finds a specific log file. And then it creates a table over that log file with schema. It says that first column's date, the second column's time, the third column is a string. It's client IP and it's a string. Once I have it, I want to query it and say, please aggregate all my hits by date, and then output it to my daily summary.csv. And if I submit that job, it just begins, it creates that job and it executes that job. Now, another major powerful thing about Azure Data Lake Analytics is that it combines C# with uSQL, the SQL-like language that you're seeing me use here. What that means is every script has a code behind file. And that code behind file in C# allows me to use all the power of the .NET framework inside my T-SQL script. Now, okay, I know I've gone over and we're at 1 hour, 20 minutes, and most of you are still here with me. So I'm just going to talk about one thing about why this is so cool. You guys are T-SQL developers, right? And when you guys run a T-SQL script, you're used to sometimes SQL will parallelize it for you. It will take your query and it will run aspects of that query in parallel. And when I talk to DBAs about that, DBAs are really angry sometimes about it because they can never predict when it will parallelize it or when it will serialize it. And sometimes the parallel plan is faster and sometimes the serial plan is faster, right? And so they're like, I just run a script and then the optimizer in the background is making parallel decisions for me and I don't have control over it, and they can get frustrated by it. But I want you to take a step back and appreciate the enormous power of having something else decide how to parallelize something for you. That is enormously powerful. Now, in the C# side, nothing gets parallelized that isn't a deliberate decision. And so we have to use like the parallel task library. We have to use threading. We might have to do locking and syncing. Like, there's a lot of overhead to parallelizing something in C#. And so when developers parallelize code, they do it very deliberately, and they know they're doing it and creating a debugging issue for themselves because it's hard to debug, and it's hard to even track it in their minds. So they have to like make a very specific decision to parallelize something. And when they go to T-SQL and it parallelizes for them automatically, they're like, yay, that was so easy, that was so great. So what I'm telling you is use SQL lets you write C# while having another engine make the decision to parallelize it for you. And it does that through multiple vertexes. In this case, it didn't parallelize it. It only used one vertex. But if I had 5 or 10 vertexes there, this would be Data Lake ADLA telling me, hey, I decided to parallelize this for you. And without me writing all the code for it, which is enormously powerful. So hopefully you can see all the different products that we have here in the cloud. You know about the competitors to these different products. There's a lot more we can do. We can use MongoDB in Azure, Postgres, Redis Cache, MySQL, Oracle. Guess what? You could use MongoDB in Azure and it's supported, which means you could call Azure with your Oracle question or your Postgres question, and Azure won't hand you off to somebody else. Azure will debug your code and Microsoft will answer your question. It is a fully supported product in Azure. In fact, Gartner thinks that Oracle support is better in Azure than it is directly with Oracle. So that's an impressive statement. So you can use any data source you want, not just the ones that we've been talking about. And at Build, there will be even more exciting announcements related to this in the future. So I would tune into the Build keynotes because we're going to see even cooler things coming. And you guys, I hope I took I calmed Azure down a little bit. You could see what your options are and you feel comfortable with some of these tools. I appreciate you staying. So many of you stayed with me through the demo pane, and I apologize for that again. And look, I appreciate your time. Thanks for spending some of your day with me.
All right. Ike, we do have a couple other questions. Okay. And I figured I can cover these real quick. One of the questions is about Azure SQL Database, asking if Microsoft didn't just announce support for SQL Agent. And I think they did something about that, but I can't recall it offhand.
I have a terrible memory, and yep. They're recording this, and I'm under NDA.
Okay.
So I don't know what they've announced, but I can tell you they recognize the pain of not having SQL Server Agent, right. And they are prioritizing correcting it. So I can tell you that because they have said that publicly.
Right. And then, let's see, where did the one go? There's one that I was looking for. Can you run a local version of DocumentDB if you have the proper enterprise agreements with Microsoft? You
can, but you can only, it's really only for development. It's really not a production tool.
Great. And then the other question is, can the attendees get a copy of your slides after the fact here?
Yeah, if you go to ikeellis.com, you can look at SlideShare, and my slides are all up on SlideShare, and they're also on my blog, and my blog link is on ikeellis.com too. And stay tuned. I'm always on podcasts. I sometimes have appeared on .NET Rocks a couple times and talk Python to me, and I am writing a new edition of my book, Developing Azure Solutions, that should be out in the fall, hopefully, if all goes well.
All right. Well, that sounds great. I think I've covered most of the questions that make sense to continue discussing. So with that, I'm going to say thank you again, Ike, for presenting with us today. And thank you, everyone, for attending the session.